Amplitude is the distance from the midpoint to the crest or trough. And this is an example of amplitude. Crest, top point of a wave. That's a wave of a crest. And the frequency is the number of back and forth vibrations in a given time. Trough, low point of a wave, and an example of that. Wavelength, the distance between one crest or trough to another.
Okay. Wave speed depends on the medium in which the wave moves. Wave speed equals the frequency times the wavelength. Also, the higher the wave, the higher the energy. The lower the wave, the lower the energy. When energy is transferred by a wave from a vibrating source to a distant receiver, there is no transport of matter between 2 points.
One example of how waves would transfer energy is an earthquake. As you can see, if a person is experiencing an earthquake, the focal point of the wave's route will move everything else. Like as you see, this would overturn the car and destroy buildings. And cause accidents. So as you can see, an earthquake would be a good example of the transfer of energy. And high amplitude would be the cause of the earthquake, which would cause a motion to move the earth through waves. This would be an example of a high-frequency wave. And now it's moving up to a low-frequency wave. Because of the larger waves, you can tell that it's a lower frequency. If it has smaller waves, it would be a higher frequency wave.
Now, here are some more physical examples of the wave. At the top point, what do we have here, class? A crest, yeah. At the low point, we have the trough. And if you look in between, oh, that's covering it, between the lines, that would be correct. The frequency. Wait, nope, that's not it. Wavelengths. Forget this. Forget it. Wavelengths. If we were to put a line straight down the center, the top to the midpoint would be the amplitude, and that is very important in determining the wavelength.
Wave speed. The speed of a wave depends on the medium through which the wave moves. Sound waves, for example, move at speeds of about 330 meters per second to 350 meters per second in air, depending on the temperature, and about 4 times faster in water. Whatever the medium, the speed, frequency, and wavelength of the wave are related. Consider the simple case of water waves. Imagine that you fix your eyes at a stationary point on the surface of water and observe the waves passing by this point. If you count the number of crests that pass each second, the frequency, and also observe the distance between the crests, the wavelength, you can then calculate the horizontal distance between a particular crest moves each second.
If a train of freight cars is each 10 meters long, rolls by you at the rate of 2 cars each second, what is the speed of the train? Here in Chapter 25, we compare the train to the wave motion, where the wavelength corresponds to 10 meters and the frequency is 2 hertz. Then wave speed equals the frequency times the wavelength, and that is 2 hertz times 10 meters equals 20 meters per second.